In the next section, we're going to figure out what the vertex is. The first bullet says a parabola is symmetric about the axis of symmetry. I talked about that briefly in the very first graph, and we'll talk about that more as we move on. The second bullet, the bottom or top of a parabola is referred to as the vertex, and a vertex is an ordered pair always written in XY. Okay, the x value of that ordered pair is negative b over 2a. That's why it was so important in the last video for us to identify what a and b are. The y value of that vertex is found by substituting our value of negative b over 2a into the actual equation that we're given. In problem 4, it says calculate the vertex of f of x equals 2x squared minus 4x plus 8. Okay, so we're going to calculate the vertex with this concept that the x value of the vertex will be negative b over 2a. I'm going to start off by writing that formula down. X equals negative b over 2a. If we look at our function, we can identify a value for the letter b. What's the value for b? Yeah, it's a negative 4. Now b is negative 4, but our formula also has a negative in it. So it will be a positive, yep. And in our denominator, we will have 2a, which means 2 multiplied with a. And what was our a value? Yeah, it's positive 2. It will. In the very end, all of this will equal 1. And the 2 negatives on top make a positive 4. The multiplication of the 2's in the bottom gives us positive 4. And the result is positive 1. Okay. That is telling us so far that our vertex is going to have a location with the ordered pair starting with a 1. Now we need to figure out the y value of that vertex. What we do is we take our answer of 1, we substitute it back into our function, our original function. So we are familiar with that work. We would write f of 1, which equals 2 times 1 squared minus 4 times 1 plus 8. Follow your order of operations with the right-hand side, which will be 2 minus 4 plus 8, which will give us 6. I'll do a quick sketch then as if I were graphing this, and like I said, it's just going to be a quick sketch. I know my vertex needs to be at the ordered pair 1, 6. My vertex would be in the first quadrant right about there. Now, the other piece that we know from what we've already done on this page is the direction our parabola would open. If we look at the a term, our a term was positive 2, which means our parabola would be opening up. So I could draw a parabola through that vertex, attempting to be symmetric, and I would know my parabola in general would look like that. Any questions before we move to the second page? On the second page, I have an example that goes through many different steps, and what I'm attempting to do with this example is show you all the different steps that you would have to go through to create a very detailed graph. The example is f of x equals x squared minus 4x plus 4. The first thing I need to do is find my vertex, just like I did on the prior page. I remind myself that the x value of a vertex is negative b over 2a. I look at my equation and recognize that my b value is negative 4. and that my a value is positive 1. Then I simplify the formula. The two negatives eventually do make a positive, and the 4 divided by the 2 ends up giving us a 2 in the very end. Okay, so the x value of the vertex is positive 2. And you'll see that I wrote that when I wrote the sentence, the vertex is ordered pair 2, comma. Now I found the y value by taking that x value of 2, substituting it through the function. So I had 2 squared minus 4 times 2 plus 4. And 2 squared is 4. The product of 4 and 2 is 8. And then carrying out our order of operations further, I got a value of 0 for y. Okay, so I found my vertex.
Why don't you use the 2 f of x at all?
Remember, that's just a bookkeeping notation, and it tells us that I'm putting 2 into the function.
Yeah.
So this side, we do nothing with it. Yeah.
But for the test, would we have to use those?
You could use the letter y instead if you want.
No, but do we have to
You can just plug it back into the equation and only have the right-hand side of that. That's fine. A lot of students will also replace this f of 2 with just the letter y because they know it's the y part of their ordered pair. That's also fine. Yeah. Okay, step 2 is we're going to create a table with our answer from step 1 in the middle of the x column, and then we're going to add to the x column numbers that are less or greater than that vertex. In step 2, I found that the vertex was 2, 0. So what I do is I create a table of values, x, y, and I put that vertex down, and you'll notice I put it in the third row down, basically. And then what I did is I magically said, what are numbers that are larger than 2? And that would be 3 and 4. So I put in row 4 the number 3, and in row 5 the number 4. And I asked myself, what's smaller than 2? And I did 1 and 0. You want to make these in order from smallest to largest. And you always want to put your vertex in the middle. And the reason is that parabolas have symmetry. And by putting the vertex in the middle, you're going to see symmetric values going on. Once you have your x values in the table, then it's a matter of following arithmetic. And what I did is I put in the x value of 0 into my function, and you'll see where I just put the blue arrow that I changed it. Instead of writing f of x, I just changed it to y. Okay, so I'm saying y equals 0 squared minus 4 times 0 plus 4. That's coming from the equation. I carry out my arithmetic, and I got 4. So over in my table of values, I now know that I had the point 0.04. I put my next x value in, which is 1. And when I put 1 in, I have 1 squared minus 4 plus 4. I carry out that arithmetic, and I got a y value of 1. Okay, I repeated that for the x value of 3 and the x value of 4. And the nice thing is that when you look at your table of values, you'll find your vertex in the middle, but if you were to connect the y values right around that vertex, you're going to notice they're the same number. If they're not the same number, one of them is wrong because there should be symmetry. And then if you go further, the very top row and the bottom row, those should also have the same value, once again because of symmetry. So if you are not getting the same values, somewhere your arithmetic is off. Well, we have a vertex. We have 5 points we can graph. With those 5 points, we can easily create a very detailed parabola. But some other details that you're going to be asked to find in your homework are what we call x and y intercepts. So what I would like to do first is plot these 5 points on the graph, and then we can go over the x and y intercepts a little further. Okay, so our vertex was at 2, 0. That's the point I like to put on my parabola first, is my vertex. And 2, 0 is on the x-axis at 2. The other points that we have, I'm going to select 1, 1 first. So the ordered pair 1, 1 is also in the first quadrant. Then I'll go up and I'll put the ordered pair 0, 4 on, and that happens to be on the y-axis. Then I'll put 3, 1 in. That also is in the first quadrant. It's exactly opposite our 1, 1, which is showing our symmetry. And our next point is 4, 4, which is good because it matches up with the point on the y-axis and really shows us our symmetry that we have. If we connect those points with a U shape and really try to make it a U instead of a V, that would be our parabola. If I go back to the concept of the x and y intercepts, you'll see up in step 4 that I typed identify the x and y intercepts for graphing. And the sentence says the c value is the y-intercept. If you remember, the equation had been it had been f of x, sorry. It had been f of x equals x squared minus 4x plus 4. And you can see that on your paper, but I can't without scrolling up. If you notice at the very, very end, this plus 4 is our c value. That c value is always going to be your y-intercept. And we can verify that because our parabola crosses the y-axis at 4. So we can see our y-intercept is 4. And I actually wrote it as the ordered pair 0, 4 when I typed it in the sentence. When you type it in Math Excel, it'll probably ask you to write it as an ordered pair also. The next sentence says the x-intercepts have y values of 0. And this particular parabola, the x-intercept is 2, 0. There's only one intercept. But graphs can have 0, 1, or 2 x-intercepts. So just to reiterate, over here on the graph, our y-intercept is the ordered pair 0, 4. That's the y-intercept. And in this particular parabola, we only have one x-intercept. Happens to be the ordered pair 2, 0. Intercepts are where they intersect the axes. It's a nice root being the same, intersect and intercept. Another detail that is not really typed up is our axis of symmetry. If I were to put an axis of symmetry in here, it would be a dotted line that we would put through our vertex.